Hello, it's David. Yes, once again, a video starts with me staring at my STFM motherboard in all of its naked glory. Story behind this, obviously, was that I'm building various add-ons, hardware add-ons to the ST range, and this little beast down here is the DSTB1 accelerator. Have a look up here for more information. And this was built using my STE. Now the problem is the STE and the STFM don't behave quite identically, so I thought I ought to probably get myself an STFM to test this with. And of course the same applies to all the other things that I'm putting together on the ST series. So I didn't want to go to the palaver of having a whole new computer, so I just bought this motherboard. And over time I've found that I'm whipping this out more and more to test things in parallel, to work on things in parallel to development that I'm doing on the PiStorm ST, again, up this way. And I really need to get this into a condition where I can use it more frequently. So we've seen a few upgrades already. This is the switchable ROM down here. Again, that one's been documented. We've done some mandatory resistor pull-ups, which is available again in another video up here. You can see I've got my GoTech in here. We've got my accelerator in here. I haven't yet tackled the memory. That is on the list of things to do. It's only got 512K in here. Obviously, there's another 8 megs on here, but this is the ST RAM. So that's an issue. The keyboard that is being addressed, but I don't have a power supply for this. So what I've been doing is I've been taking my Rolls-Royce power supply. If you want to see, by the way, a video about a brand spanking new build power supply from Exxos, here again is another link up here for you. But I only have one of those. That's in my STE, and that is the absolute duck's nuts. I would like just a power, a small, lightweight, cheap power supply for this that's not going to electrocute me. Now, the normal STFM power supplies look like this. This is a second-hand one that I've picked up, and this is, I think these capacitors have been measured and they are pretty much knackered. This one's swelling. I wouldn't want to put this in here, not unless I really had to. But it does come with a bracket and a switch and the IEC socket. So I'm thinking to reuse this bracket, but with one of these little, and these are quite ubiquitous, Meanwell power supplies that has fallen into my lap. Now this just popped up cheap on eBay, and I thought I'd give it a go. I know quite a few people are using these with Amigas. These are clearly not going to have quite the same level of regulation that the Exxos power supply had that I've installed previously. But that is a premium product designed to keep these boards going for as long as possible. This is my bubblegum throwaway board, really, just used for testing my own products. So I'm not that concerned about this one. The STE I really wanted to keep in top working order. So this should do the job nicely. Now this provides 2 outputs. It's got a 5-volt rail that can support up to 6 amps, and a 12-volt rail that can support up to 2 amps. Now I can't remember exactly what the specifications on the old ST supply are. Here we go. We've got a 5-volt rail at 3 amps, so more than adequate. We've got an overhead of 100% on that, and the 12-volt line of under 1 amp. So again, we have a huge margin of 100% overhead. So we've got a 200% rating on it. So what I was thinking to do is to try and get this somehow to fit into this gap. Oh, incidentally, by the way, one of the major advantages of this is all earth. This is properly shielded. This doesn't have a case. It's never likely to have a case unless I can get one of the new 3D printed versions that I think Icky is working on over on the Exxos store. But this can hopefully reuse the bracket, perhaps potentially the IEC socket here and the switch, if I can make it fit, which I might not be able to, but we'll give it a go. If I can't use the bracket, then I'll just route the power line out and bypass the switch. But anyway, if I can't, sorry, you refit everything on here. But the bracket, I think, should be usable. And we'll try and get this set up. And I'll do a little bit of measurement at the end, but I'm not really a power supply tech, as can be seen from me trying to do ripple measurements on my older Falcon PSU video after the recap. Again, that's up here. So I won't really know, let's be honest, what I'm looking for. But I'll show you a screenshot if I can get it all up and running. So that's the plan. Let's take the PSU apart. Okay, so here we go. First things first, we'll get the actual board off and then we'll desolder the wires. Doesn't look terrible for a board of its age, but I don't plan to use this anyway. This heatsink is, by the way, at mains potential when in use, which is why this is a bit of a no-no for leaving out. There we go. That is the switch and the main power inlet isolated. That's all it is. The two wires there going in. We've got ourselves. I suspect the black is neutral and the white is your live, but I will buzz those out to make sure. When we look at our input here, we've got the live and neutral over here. Those will correspond. But we're going to have to unravel those. I suspect we're going to have to mount something like this way around. That is it's going to overhang if we keep the switch and socket in place. It's going to overhang on this side, you see. We don't need the insulator anymore because this is actually an earthed chassis. So we'll want to actually screw into this. We've got two mounting holes here. And I'm not quite sure what these ones are for down here. I can't see if those are mounting holes or not. They look like they might be, but I'd be a bit reluctant to screw too deeply into those. Interestingly, there's nothing else on here. Maybe this is a castellated kind of a mounting hole over here. So that might be the trick. There, and there. So we'll have to see what we can do. It may be actually that I anchor a couple and a cable tie will secure the other corner. We'll investigate. And if we can't make it fit, then these, of course, can come off, and I'll just route a power lead out instead, and we'll forego the switch. I am going to desolder. Actually, maybe I won't. I was going to desolder the plug here and use this as an extension. Because we are going to need to route a longer cable to the motherboard. But I do have one previously salvaged from my old power supply when I replaced the STE power supply. So I've got one here already, but this is also going to be too short. So I think what I'll be doing is trimming this and putting extensions on. I've got a couple of flex. Power lead flex here. This one is just twin core, but this is, what have we got here? See, this is rated for 3 amps, so this is a 0.5 square millimeter cable, I think. Yeah, 2.5 square millimeters. That's absolutely fine for 3 amps. So I could extend with this using the brown for the 5 volts, the blue for the ground. And then we would probably have to use another brown on the 12, or maybe I'd drop down to a different cable for that, because obviously that's far less current draw required. So I'm going to put that one to one side, and I'm going to see what we can do about the arrangement here. Okay, so I think this switch is a bit dodgy, actually. Apologies about the background noise. It's torrential rain here at the moment, so if that's coming through, sorry about that. I am, after all, in a shed. let's get the clips out on this one. Okay, so that's I believe that's the live pin I'm clipped onto there. So I'm expecting this one to make continuity when I throw the switch. So right, here we go. No, obviously open loop at the moment. Nothing. Okay, let's try the black. Aha. A bizarrely decreasing, oh, well, fluctuating resistance. Yep. That's the switch, isn't it? Look at that. Open loop, bit of manipulation, jumps around all over the place. Hold it halfway, works. Yep, okay. So we have a dodgy switch here anyway. I can get some contact cleaner in there. But given what I was saying about the layout and the tight fit with the power supply on the board there, it may actually be in our interest to simply bypass the socket and the switch entirely and just run a cable at the back. Let me just try. This is the well, I think this is meant to be the neutral side, but for some reason it's wired up to the white. Yeah, same thing. Okay, bad switch. Probably makes our mind up for us. Okay, so I'll put one corner in there. Obviously it overhangs a little bit here, so we've got potential holes in these spots here. I'm just wondering if there's any other option I have. I might try undoing this and see what's underneath. But what I was thinking was if I've gone into that corner there, perhaps I can squeeze a little nut or something through that one there and drill a hole in the plate at the bottom. But I need to open it up and see what's underneath. Coming from that angle, I can't see. There's my hand underneath. Might need something lighter, might need some paper. Yeah, so coming from that angle, I don't know if you can see, there doesn't seem, actually that's not clear at all on the camera. There we go. Look, there doesn't seem to be anything between the bottom board. So I might be able to fit a little bolt head in there, and so go through this hole here. So let's open up the back of the power supply and see which way the land lies. I think this might be a security seal. I think this needs to pull backwards this way. Looking at the way that the way that things are moving in that gap there, that looks like that needs to unhook in this direction. And I think that's what is limiting it. So I may need to. Oh. I just pulled it out with my fingernails. Fair enough. So I'm pulling that back. Well, there we go, and it folds off. Okay. All right. Wiggle, wiggle, wiggle. Is that stuck down? Yeah, I think I can see. I think I can see some bonding down in there. So, Okay, well, unfortunately, I can't see an easy way to take this off without debonding this heatsink here. And so I don't think I'm going to. I think what we'll do is we'll screw in the one corner that's easily accessible, be it this one, or if we turn it around this way, it'll be over here. And we'll make sure that's got a good earthing connection. And then I think we'll just cable tie it. It's my, you know, it's my testing, my experimental machine. It doesn't have a case, doesn't it look pretty? Okay, so our cable has to plug in here. So we can't mount the unit any further this way. I actually have no idea if this would fit in a case, if I had a case. I mean, obviously I don't, so it doesn't matter. But so that does mean that we're going to have to go with the rearward mounting, which I suspect does rule out us putting back in the socket. Perhaps if I cut off the connections, routed it sideways. To be honest, I don't think we're going to need that. So that's flapping about a bit there. That's actually the bracket, I think, being bent. Not making good solid contact here. I don't have really anything to screw it into, unfortunately, so not unless I actually put a bolt through there, which I could do, I suppose. But so that's a bit flappy, and we need to somehow get these wires around to the way this is laid out is that we've got the so that's 5 volts ground, 12 volts ground. So I would need to snake these wires around the side and into here, and bring my AC in here, or we can mount it the other way around, and these would have to snake. Well, this is not going to be long enough, so they'd have to come around this way, and the AC come around this way. So I might just try it in that orientation to see whether I prefer the look of it. Right, that's going to suffer the same problem there. We can't actually see, so this is with it turned around the other way. We can't actually even see the connector. So I think, as we had it a minute ago, is the way to go. So just going to check that only soldered up one, just going to check that reaches. So that'll plug in there and it'll route round, and there we go. So I would say that's fine. That's the 5. That's the 5 rail. 12. Let's have a look. We would go this blue one here. Oops. Let's imagine that's joined about there. That needs to reach around to that one there. There we go. Yep.
Let me give you some news from this channel's sponsor, PCBWay. A year ago, PCBWay moved into a new factory, and now they've had time to get their feet under the table, they're able to offer some substantial price reductions. There's up to 20% off 4 and 6 layer boards, bulk order prices are down, and 5x5mm track width and 1/4mm minimum hole size designs will also see huge discounts. The event started on the 5th of August 2022, and you need do nothing special to obtain it. Why not log in now and see if your design, manufactured to PCBWay's normal quality specs, is much cheaper than you thought all of a sudden. And if you're there, maybe take a look at their CNC machining, sheet metal fabrication, 3D printing, and injection moulding services whilst you're at it. See the links at the bottom of this video for more information.
Okay, so there we go. That's our 6 lines extended. We just I do have some crimps here to terminate them with. Perhaps either these ring ones here or the spade fork. I suppose they're not spade, are they? These fork terminals here to slide over there and get screwed in. This would be the ideal way of doing things, and obviously we'd have to crimp the got to try and crimp the multiple ones together, so probably the two 5-volt ones would have to somehow go together in there. And be crimped together like that, I think. We can give that a try, because I don't think I'd be able to get 2 of these in. 2 of the actual terminals. I don't think I'd be able to easily get them in. You know, do you see what I mean? They'd be blocking each other, going into the screw terminals there. So I think the trick would be to make sure that both of the wires, there they are, you see 2 of them down there. Both the wires go all the way through into the brush zone there, and they get crimped together. So we'll give this a try. So I'm using the red, which is the smallest of the 3 color types I have here. And you'll see on my strippers here, there's a red, blue, and a yellow. And the idea is that we just give them a squeeze. That is it, that way or that way? I think it's that way. Let's give it a try. That's, to be honest, that's fairly firm. I might be tempted to actually try and pour a bit of, get a bit of heat in there and pour a bit of solder down the top. To be honest, because I know you're not meant to. I know you really aren't meant to with crimping applications. You really are supposed to rely on the physical squeeze there. But I would be very tempted to anchor that with a bit of solder. But anyway, let's keep going. Okay, I'm going to wind the wick up a little bit on my soldering iron. I'm going to go up to 350 here, and I'm going to go against general guidance, and I'm going to try and pour some solder down there, because the truth of the matter is I suspect that these I don't actually know what this wire gauge is, or the equivalent of this wire gauge. I suspect that, to be honest, this crimped terminal is too large for my wire, and so I think that's why it's a little bit loose in there. That one's not too bad, it's not moving around, but some of them are. The double ones actually feel better, so I think that's probably what it is. So I'm going to reinforce it a little bit with some solder, and we're going to see how we go. I've not tried this before, so I'm going to try heating the wire and the thing at the same time, and the spade, and I'm going to just touch into it, see whether any of this rolls down. That doesn't look too bad. In fact, can come across on the camera. That's kind of flowed into that pocket, and obviously the end was tinned anyway, so that feels all right. I'm gonna go with this. As I say, I know this is not received wisdom on the for you crimping aficionados, but yeah, you can see there's a big gap at the end there. But here we go. I'm sorry. Needs must. Right, well, let's just double check that. We've got 2 reds, which are 5 volts line, going to 2 browns. We've got 2 grounds going to 2 blues. We've got a further ground going to another blue. And we've got our blue, which is our 12 volt line, going to another brown on account of me not having a suitable third colour. This should be an easy wire up then. We will be making sure that all of these are measured on the voltmeter before we do any powering up of the ST. And then there's our final one. I think that might have come over the top. We'd route that depending on how much space we had in the event that we actually had a case. Which, as I say, we have neither a case nor a keyboard. Okay, we're in, we're good. Right, so now we turn our attention to the power line, the mains line. So I've got myself cut down 2 meters here of 3-core flex. This is actually a 0.75 square millimeter cord flex, which is far too much. It's massive overkill for our task. These are capable of handling 6 amps each, and we need a fraction of that. We need below 1 amp. We're going to put a 3 amp fuse in. But yeah, this is overkill. This just happens to be what I have available. A couple of meters I thought is probably sufficient. What I may do in the future is to put a switch, an inline switch in here, but I don't have one at the moment, so this is going to be a plug it in and out of the wall job. So I'm going to strip these down, and I'm going to strip these down to the UK plug specification. So if for our overseas viewer, if you are not familiar with UK plugs, how they work, this is a standard 13 amp plug. I've undone it here. This is what it looks like inside. We've got the main earth connection at the top there. This is live, which goes through a fuse. 3 amp is the smallest rating fuse that will fit into these sockets by standard. You have 3, 5 and 13. And this is the neutral connection down here. And the idea is that the shortest wire of the 3 will be the live, and that goes straight through, so that in the event that the item is inadvertently tugged on, the first to disconnect will be the live, isolating the product. Second to disconnect, if a really hard tug, would be the neutral, and the last to disconnect with a snaked wire leading up to it will be the earth. So we have to cut the lengths of the flex in such a way that I think it's something like 16, 20 and 25 millimeters. Don't quote me on that one, but it's roughly of that order. And then this is cable strain relief here at the bottom, which gets tightened up. You notice on the On the facing side, the 3 pins, the earth pin is all metallic and is the longest, and that leads, and again that would be the first to make contact when you plug in and the last to disconnect when you unplug, for safety's sake. The live over here and the neutral over here have insulation down the sides, so that if you're pulling like that or putting it in like that, you can't physically get your fingers touching them as you're half connecting. So it's a pretty good design. Oh, by the way, it plugs in to the wall like if you sorry, I have to rotate me through 90 degrees. So it plugs into the wall like that, and the cable comes out this way, which means a tug in this direction provides a torque turning force, which again would disconnect the live and the neutral before the earth in in a really extreme case. But to be honest, that's hard to shift because you're providing a torque force in this direction rather than a pulling force straight out the back. So they're very good designs, been around for years and years, and it's all down to a lack of copper, I believe, after the Second World War. So our ring mains, the idea is instead of a hub and spoke model in the house, you have one big ring around the house which can carry 60 amps or something mad like this. So each plug has to be fused and be particularly have particularly high safety standards. Anyway, us aside, I think there's a good video on this. I'll link it up here if I can find it. So those are our 3 different lengths there. So we'll just try and balance the strain relief here so that we screw down equally on both sides. I think that's pretty much done. There we go, nice and safe. Now with this one, for the sake of safety, I am going to use the ring terminals, which means we will unscrew the screws all of the way in the supply here, and then screw through them. And that means even if these work loose, our live, for example, won't come flying out and shorting out on the chassis. Okay, so I might come in through the power switch, I think. Could still insert a power switch here if I can make it fit, but just going for the basics at the moment. And we can apply some strain relief here with a cable tie or 2. But let's obviously connect up the most important one first, which is earth. And actually, I think we probably ought to bring an earth strap over to this as well, because this is only relying on that one connection down here at the moment, which I don't think is sufficient to make me feel comfortable, to be honest. Right, so we take our screw terminal out, we'll pop it in there. There we go. There we go. Perfect. Okay, so what I've done is I've cut another length of earth core here. We've gone, you see, we moved up to the blue here because I fitted 2 in here. We've fitted 2 into this terminal, which will now hopefully fit into the earthing connection on the Meanwell, like that. And we're going to come over with this fly wire here to the probably that way around, isn't it? To the earthing point on the bracket itself, and obviously the bracket should be electrically connected to the Meanwell. It's only done so at the moment by one screw over in that corner until I come up with a better solution. So I want to make sure that we've got the earthing connection through to the frame itself. That washer should probably go on that side, I think. There we go. And of course the frame attaches to the ground point on the motherboard. So this earths the whole shebang. Right, so here we are, got the motherboard back in situ. We should be able to take our newly constructed supply, click this into place here, just get the power lead out of the way. Already moving around. There we go, that slots into place. Okay, so on this side the cables are sticking out a little way, but I don't think that's an issue because I don't have a case. That plugs in there. They're all nicely insulated, that's fine. I mean, I could always wrap that in up like that a bit. There we go. I think that looks pretty good. There we go, that's how it looks from above. We've got our grounding strap there. We've got our power lead coming through here with a bit of strain relief. Perhaps upon reflection that comes out too close to the monitor. Maybe I could take it through there. I don't think there's enough room for me to fit the IEC on there. I could put it on the outside maybe, but I'm not too worried about that. If we need to put a switch in, an inline switch in the cable itself is probably the easiest option. So that should go in, and I think one thing is needed to improve the safety here. This is earthed and it's all nicely protected. That's connected through to ground. We've got a strap on there which connects that ground to earth, but these terminals are exposed. So what I've done is I've gone on to Thingiverse and done a bit of a search, and my 3D printer has popped out this. This, to be fair, doesn't quite fit. I'll just give it a go, and you can see it's a little bit bent there, but that's my printer settings, I'm sure. This is a insulating hat for there we go, that just slips over there like that and provides a little bit of cover, well actually quite a good amount of cover for prying fingers. So quite happy with that. Let's unplug the motherboard plug. We'll just measure some voltages unloaded before we plug it in. If it's a little too high unloaded, I'm fine with that. If it's massively too high, then we'll have to get out my big power resistors and do some proper measuring. Okay, so we've got the multimeter out. I'm going to clip my ground onto the chassis here. So what I should be expecting to get is 5 volts on this pin and this pin. Should be at ground there, there and there, and we should get 12 on that. And if I have trouble measuring from there, I can always pop a header in, and we can measure from there. So I'm going to hold that up so it doesn't short out on anything whilst I plug in. And well, fingers crossed. We've got fuses throughout here. This carries a fuse, and my my plug you've seen me assemble carries a 3 amp fuse. It's got a 1 amp fuse. So let's plug in and see, and hope we get no bangs. Okay. I don't smell anything. Didn't hear anything. There should be an LED on there somewhere, but I can't see anything either. So let's try a measurement. So I'm going to go for the first 5 volt line. That's not good news. Let's try the 12 volt line. That's also not good news. Is this because it's unloaded? Could be measuring capacitance here. Or the inductor maybe. Right, okay. So that's not working for me. I can see the green LED down in there. Just see it peeking through there. Oh, of course, I suppose it's always possible that Earth and 0 are not actually the same thing. Yeah, no, that's entirely feasible, isn't it? So let's. It's all still plugged in. Again, not hearing any bangs. Let's just get the probe out, and we'll get a different clip. Okay, so I'm going to connect to one of the earth pins there. That should be nicely isolated, and that's going to get, not the earth, sorry, ground, and that's going to be clipped onto my negative probe. Oops, taken safely off here so there's no shorting going on, and we'll bring back in the positive probe and see what we get this time. So now this is not connected to ground, sorry, to earth, but to ground. And there we go. Haha, so it's actually, that's interesting, it's actually isolated. Didn't realise that. I mean, obviously it would be connected through the board, but at the moment the ground and the board aren't connected. So we've got 5 volts on that rail, 5 volts, 5.06, perfect. Obviously then that should be ground. That one is connected already, that should be ground. And this should be plus 12. 11.6, perfect, right. Happy with that, let's unplug. How quick does that die away? Pretty quick, good. I mean, these are meant to be decent supplies, and they probably just don't have the same, anywhere near the same protection and characterization of the Exxos supply that I installed. But I mean, for an old machine that I'm not that worried about, they should be perfectly adequate. Right, so let's connect up here. We are in. Let's find our monitor lead. We have it set to color. Not that it makes a difference. And time to cross our fingers and see what's what. Unfortunately, I don't have any keyboard on here, so this is probably going to make a noise. Well, it would actually if I don't have the speaker plugged in. So this is obviously not going to be an ideal test, but we should see power come on here, and then hopefully the monitor should drive. So I'm just going across to the power again, and we're plugging in now. There we go, flash floppy comes up, and yes, perfect. The Emutos desktop is here, and yep, sure enough, it can't find the time and the date because there's no keyboard controller attached. Okay, so the only real thing left to look at here is the performance under load. So what we've got is the oscilloscope set up in DC mode to measure the the peak voltage, the Vmax. We've got a bandwidth limit set on to rule out anything over a megahertz, and we're going to throw the switch. There we go. So we are showing. Silly me. I was in 10 times mode, 1 times mode. Right, there we go. So here we are down to 2 volts per division, and we're reading 4.96 under load from the bulk capacitor. I've got the probes across the bulk capacitor here. We've got the ground on the negative, and we're measuring across the capacitor itself. So that's good. Can we pick up any real ripple? So let's switch it into AC mode, and we'll wrap the scale right up. There we go. So volts is at limit. Okay, there we are. We're seeing a few little bits and bats. Let's see if we can measure. Again, I don't know what I'm doing here. This is not my area of expertise anyway. We'll go from the peak to peak. I'll zoom out a bit. So we're seeing things in the region of, okay, 40, 50, 30, 80, 100 millivolts peak to peak. Okay, there we are. Yeah, 108, 120. So time base comes out. Yeah, so, okay, 114, 92. Okay, so, I mean, we're seeing, oh, there was a little spike there, little drop. So, we're seeing a few ripples there. We're looking at something. The relative. It's not ripple per se, is it? It's spikes. The ripple is pretty much negligible. Yeah, there's no sort of like obvious repeating element to this. So we're seeing a few spikes here and there. There we go. 200. So, all right. If we're looking at two. If we're looking at 200 millivolts, that's really pretty negligible at this level. And yeah, I'm not seeing. I'm trying to just vary the trigger up and down here to see if I can get any regular pattern. So I'm going to say that the ripple is practically non-existent, and we're just maybe there's just an absolute hint there, but it's bear in mind the peak to peak here is showing at 50 to 100. The actual ripple then, superposed on the background there, is very small indeed. And this is with the accelerator in place, running at 16 megahertz. This is actually running at 16 megahertz at the moment. It's detected the alt ramp, so there is more load on this. Okay, it's got a GoTech instead of a real floppy. There's more load on this than would be normal with just an idling machine. So I'm going to declare that a win. Okay, so there we go. That is a Meanwell 50 power supply that's been repurposed as an ST replacement supply. Is that the neatest thing in the world? No. Is it the most perfect fit in the world? No. Would the case go back on with this in place? That I'm not yet sure, because I haven't got a case. Will the keyboard even fit? Again, we're not sure, don't have the case. However, will it do a job for an old machine that has no supply, but is not your most dearly beloved treasure? Yes. Is it going to be as good as a dedicated Exxos supply or others that are intended exactly for the purpose? No. Is it going to be better than your original? Well, I'd say yes, it probably is. So, all things considered, I'm going to give that one a thumbs up. Thanks for watching. See you next time.